In this example, we're kind of working backwards. We're given the first two terms in this binomial expansion. It's going to be some a plus b cubed is going to equal 8 plus 12x, or 12 times e to the x plus dot dot dot. And what we want to do is we want to find what the original a and b terms were, and hence, using that information, determine the remaining two terms of the expansion. So let's actually start out by writing out that general expansion for a plus b cubed. If we use the binomial coefficients in Pascal's triangle, that's 1a cubed plus 3a squared b plus 3ab squared plus b cubed. What do we know so far? We know that the first term must be given as a cubed. And I'm going to kind of use that to say, well, a cubed is the first term, and the first term of our expansion is equal to 8. So what does that tell us? That tells us that a must equal 2, since 2 cubed is equal to 8. So that's good. We've got an a value, so we know that this is going to equal 2. Next up, we need to find that b value. And to figure that out, I'm going to kind of focus in on the second term of my binomial expansion and say that 3a squared b must equal this term, 12 e to the x. 12, let me try that again. 3a squared b must equal 12 times e to the x. So at this point, it might look like if I just had this fact alone, this isn't enough to figure it out. But I do know what the a value is. So this is going to be 3 times 2 squared times b equals 12 e to the x. Or I could say this is the same thing as 12 times b equals 12 e to the x. And so hopefully you're seeing that b is equal to e to the x. And that's pretty helpful because now we've figured out what a is equal to, we've figured out what b is equal to. Maybe I'll just state it one more time over on the side here. So a equals 2 and b equals e to the x. So that's our a, part A, done. Now let's figure out part B, and part B is going to be figuring out what the remaining terms are of this binomial expansion. We've got a and b, so now we're basically just plugging it into the last two terms in the general binomial expansion. So let's do that. If I take 3, and then I'm just going to fill in these blank parentheses, kind of like I did in that last, in one of my previous examples here. So this is ab squared plus b cubed. So wherever I see an a, I'm going to put a 2, and wherever I see a b, I'm going to put e to the x. So that's e to the x, and that's e to the x. So if we simplify all this out, that's going to be 3 times 2, well, I can combine those actually, to 6, and then e to the x squared, that's going to be e to the 2x. Remember, that comes from your properties of exponents. If I have something, a power raised to a power, I'm going to multiply these exponents, and that's going to be e to the 2x. And then this will be plus e to the 3x using that same power property. So I guess that entire binomial expansion is going to be given as 8 plus 12 e to the x plus 6 e to the 2x plus e to the 3x. While you try this example, very similar, we've got e to the x coming back at you again. Once again, try and find what a and b are equal to, and then complete the entire expansion. And this time it says copy and complete. So I would imagine that your full expansion should contain the entire expansion, not just the last terms of this one. So pause the video and give this one a shot. All right, and here is my solution for this problem here. Quite a bit of work, quite a lot of e's. But that's now it's E like the letter E, not E's like EZ, although maybe it was for some of you, and that would be great. But this is my work. Check it out. See if it makes sense. If you need to go back and review, do so, and I'll see you in the next video.